Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our water flood series and still about thief zone. Today's topic is about thief zone evolution. Okay, so again, I still take the information from this paper, development of a correlation to predict water flooding performance of sandstone reservoirs based on reservoir fluid properties. You can find the paper on the internet. Okay, so we have 3 bullet points here. I'm going to read it for you. So the first one is thief zone evolves from long-term water flooding. Okay, we already know that. Okay, so thief zone is actually not natural. It is induced by long-term water flooding, right? But the question is why? And then we go to the second point. During long-term water injection, sand production and clay erosion will contribute to the variation of formation structure, which may lead to a widespread evolution of thief zones. Right, so the culprit, the problem, comes from sand production and clay erosion, which resulted from, the long-term water flooding. And then this sand production and clay erosion will lead to the variation of formation structure, which may lead to widespread evolution of thief zones. So the chain is like this. The first one is long-term water flood. All right, it leads to sand production and clay erosion. Okay, and then it leads to the evolution of thief zones. So that's the chain. And we go to the third point here. After so many years, water flooding, a large numbers of high permeability streaks have evolved, which tremendously impede stable oil production. So it's a quote from the paper. The author said that after so many years of water flooding, a large numbers of high permeability streaks have evolved, which tremendously impede stable oil production. So they said a large numbers of high permeability streaks. So it's very, very interesting. All right, now we have the fact here, we have evidence here that long-term water flood will lead to high permeability streaks. So it's the problem in water flood. So if you're dealing now with a long-term water flood, you better be prepared. Or maybe you are now already facing the problem of high permeability streaks and thief zone. All right. So this is a very important learning from this paper. And now the next main point is actually this pressure transient analysis we have here. So another quote from this paper, it can be observed that there has been a streak around this well, 201181, whose permeability has increased to about 3 times as large as the ordinary formation. Okay, so if you read the paper provides us with this pressure transient analysis of a well suffering from thief zone. And the well is here, 201181. And this is the result of the pressure transient analysis. We have the wellbore storage, skin factor, streak permeability, half length of the streak, width of the streak, and vertical location of the streak. The main point here is the permeability. Okay, so 146.3 to the power of 10 to the power of minus 3 micrometer square. So we have 146.3, but if you compare it to the initial permeability, then the permeability now has increased to about 3 times as large as the ordinary formation. Okay, so now you can see now the evolution of thief zone. After long-term water flood, now the zone becomes a thief zone with high permeability, with permeability 3 times larger than the initial permeability. So the permeability now, after thief zone evolution, is 3 times that of the initial permeability. And we can see qualitatively from this pressure transient analysis, this log-log plot, we can see this is actually a fracture, a vertical fracture, shape. So we can also say that streak, high permeability streak or thief zone is one of the form of fracture, or it looks like a fracture, or it behaves like a fracture, or we can treat it like a fracture. Okay, so thief zone looks like fracture, behaves like a fracture. That's the thing. Okay, so we have so many important things from this point only, from this page only, but we have second page. Okay, the same bullet points, but another pressure transient analysis here. It also gives us the shape like vertical fracture. Okay, so again, high permeability streak, thief zone behaves in such a way that it looks like a fracture in pressure transient analysis. Okay, so if you are now dealing with water flood, you perform pressure transient analysis, you know that it doesn't have natural fracture. Of course, it doesn't have hydraulic fracture, but why? The shape of the log-log plot looks like a vertical fracture. Then maybe you can think that one of possible reason that you have the shape of vertical fracture is because that your well is intersecting a thief zone. Your well is connected to a thief zone. And let's see, we have here the strict permeability now is 16.2. And now the quote from the paper, compared to its initial permeability, which is this one, around 4, multiplied by 10 to the power of -3. I think it should be -3. Okay, the fluid flow capacity of this streak has quadrupled. So it's 4 times larger than the initial permeability. Okay, so from here we can know that actually thief zone is a product of evolution. There is a change of permeability. From the first case, we have the permeability now has been increased 3 times. And the second well here, the second case, now the permeability or the fluid flow capacity has been increased 4 times. Okay, so that describes, that explains the thief zone evolution. Okay, so let's recap. Again, we learn more that the thief zone evolves from long-term water flood. And the chain, the causation is like this. Long-term water flood leads to sand production and clay erosion. And then sand production and clay erosion leads to evolution of thief zones. Okay, and then after so many years of water flood, you can have large numbers of thief zones, large numbers of high permeability streaks. And then if you perform pressure transient analysis, then the thief zone will behave like a vertical fracture. Okay, so you can look at the shape of vertical fracture in log-log plot, maybe the typical vertical fracture shape of in log-log plot, then the shape of thief zone in log-log plot looks like that. So thief zone behaves like a vertical fracture. They have high permeability. That's one thing, right? And then lastly, if you compare the initial permeability and the current permeability after thief zone evolution, then your current permeability will be much larger than the initial permeability. Here we have two cases that now the permeability after thief zone evolution has increased 3 times to 4 times compared to the initial permeability. Okay, so many things to learn now. So thief zone is very important to learn. Thief zone is a problem in water flood, so that's why we need to understand more about this topic. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next water flood videos. Thank you.